No. It's been a while since we've gotten a product of 0 and something. That is weird that you multiply and you get an answer of 0. Can you turn and tell the person next to you, does that answer make sense? No. Because
we have it makes sense. You have to have it does make sense. So you have to move the decimal places. You have to move the decimal places.
Ask someone who hasn't said anything in a while. Does that make sense to them?
That makes sense to you.
Talk to your groups. Why do you think you make sense? Okay. How many people said, yes, that makes sense to them? Stroking my beard. How many people said that does not make sense to them? So we're kind of split down the middle. I'm going to reason through and see if this makes sense to me as a mathematician. Now I want you to really pay close attention to what I'm saying. Remember we talked about the word metacognition?
Yeah.
Do you remember what that word means, metacognition? That's perseverance. That's perseverance. What does metacognition mean?
Keep think about it. Make sure it makes sense.
How do you think about your thinking? So whether you're asking yourself if it makes sense, or whether you're asking yourself, I don't know, you're kind of stepping out from the math that you're doing and you're behind yourself watching. You're thinking about your math thinking. Okay, I'm going to demonstrate how I think about this math problem so you can kind of hear what that metacognition would sound like. So we're going to do hands down, ears nice and open. Forget about what happened in the hallway lunchtime. This is on our quiz today in some form. So I want to make sure you really have that number sense side of things. Matthew, attention. 1 and 4,200. That's a crazy decimal. I'm going to round it to make my thinking a little easier. 1 and 4,200ths. What is that about close to it?
1.5.
Now one person said 1.5. What was another thing? 1 and 4/10, 40/100. I like halves as a benchmark better, so I think I'm going to choose 1.5. Yikes, Miss Cece.
Too small.
Do you know how to write? Okay. I'm going to do the same procedure with the other factor to see if I can figure out, if I can, in my head, see if this makes sense. So the other factor, 1100ths, what is that close to? 10.
You could just add 0 on it.
It kind of is close to nothing. It's close to 10, like 10 cents or 10 hundredths.
I just noticed that
it's
it's basically like a negative.
Let's talk about that in a second. I might say that that's close to nothing. That's almost like having no money if you're thinking of money. That's very close to 0. Let me see if that makes sense then. 1.5 times 0. What's 1.5 times 0?
0.
Well, that's why my answer is 0. 1.5 times almost nothing is almost nothing. If you got an answer of 15, probably have a decimal placement issue, and that wouldn't make sense. That would be too large for the factors that we have. Okay, did you see the process of my metacognition?
Yes.
To see if it made sense. Okay. So, concerns, questions, comments now. Yes, sir.
Another thing you could have done, 0.11 is the same as 0.110.
Adding a 0 on the end, a hidden 0. So changing the way the number looks, which is a strategy we've talked a lot about in the past. And if you wanted to change the way the number looks while it's still equal, that could be a strategy you could use. My way of using metacognition, that would not have helped me, but it could help you in your metacognition. Good suggestion. Any other concerns? I know Ivan had one before.
Would there be a way to like just multiply right away and get like 15 and 1600ths and then like move it over, but how do we know we can move it over?
The question at hand is, when you multiply straight out, as if there's no decimals at all, those are the digits you get. And the question at hand is, how do you know where the decimal goes? Would you like teacher talk on this, or do you want to practice it in your groups?
No, I know.
Practice.
What time is it? Oh, we were supposed to be done with more about 2 minutes. Teacher talk? No. I know. I know that when you orally rehearse this in your groups, you kind of have a better grasp on things. But this is actually good that we're doing teacher talk now. This does show up on our quiz today, so I want to make sure we're on the same page. Take your mind back to bits and pieces 3 unit. Decimals. Lots of money. Lots of money was in that unit. One of the problems we did was the restaurant problem where you added up different amounts. Okay. In that unit, we used calculators to multiply many, many, many decimals till we found a pattern. Is that coming back to you? A little bit. A little bit. Okay. In that pattern, we found the decimal moving based on how many decimal places there were. Is that coming back to you?
Yeah.
Okay, so let me speed up this conversation then. How many small, teeny, tiny parts of numbers are in the first factor?
3, 42.
I think I just see 2.
Oh,
The
behind.
4 and the 2?
Oh, yeah.
Behind the decimal, small, teeny, tiny parts of numbers. And what's the second? And what about the second factor?
2.
So that would be 4 in total, hidden decimal. That's how we got our answer. Again?
Just count how many spaces are
Again?
behind the decimal.
In the factors, the red circled numbers, how many digits or numbers are behind the decimal point? I counted 4. 4 teeny tiny parts of numbers. That means your answer has to have 4 teeny tiny parts of numbers. So you move the hidden decimal to the left 4 times. Concerns, questions, comments? Sounds like it's better back there. Yes, sir? I just went over it and we went over it for about 2 minutes and I'm thinking maybe you didn't have super good focus. So let's talk about lunchtime's over, super good focus. I cannot repeat it again because you were not focused, but I will help you in the next part of class. Maybe Sylvia could take over that one too. One more, yes sir.
So we just count the decimals and then on both sides and just add them, and we will know how many stuff.
Yes sir. And see how it takes each of us a different amount of time. Someone just needed to look at it once and they got it. Other people needed to talk. Other people needed to be quiet and listen. Good, I like that. Bad news though. Oh, one more concern, yes,
When you do that type of problem, well, I got help on it. I got seen Caleb. But Caleb said that he guessed and got like 1 point something, and then he said lattice isn't the greatest thing.
Who are my lattice kids? My lattice kids.
You want the square?
Remember, yeah, square, remember, I took you to the back of the room during the bits and pieces 3 test, and I taught you the trick of they hold hands and go down the side. And then that was a trick, and it might get confusing later. I would always revert to this method, even if you're lattice. Because this is a way you could describe it mathematically, counting small place values and moving the small place values at the end. The other lattice way would be a trick. Like if Mr. Ariano walked in right now and said, how'd you do that? And you said, they hold hands and go down the slide together. He would say, that sounds like what a mathematician would say. That's a trick. That's a trick. So lattice kids, I would do this method. And Emma seemed unsure. I don't know if over there you can hear. She said, the student helped me, and the student said that he kind of guessed where the decimal could go. You could definitely use your metacognition to guess where the decimal goes. You could for sure. This should be a tiny answer, so then guess where the decimal's placed. And then double check with your strategies to make sure. Okay. The bad news I was going to say before?